Okay, so lesson 8 is a continuation of the transformations that we started yesterday. The transformations that we looked at yesterday were all of the form of stretches and reflections. So that leaves us with translations. So that's what we'll be focusing on today. So again, we're looking at the graphs of a sine b times x minus c plus d, or y equals a cos b times x minus c plus d. And we're trying to see what the parameters a, b, c, and d do to the graph. So yesterday we looked at a and b. What does a do to the graph?
Stretch.
Which way?
Vertical stretch.
Vertical stretch by a factor of
1 over 8.
1 over a if the replacement was a. But in this case it would actually be a factor of a, right? And then what does b do?
It's a horizontal stretch.
And by a factor of
1 over b.
1 over b. Okay? So if we look at class example number 1, we're going to describe how the graph of the given function compares to the graph of y equals sine x, where x is a value in degrees. So if I look at the first one, y equals sine x minus 30, what was my replacement? What replacement did I make on this function?
X to x minus 30.
X with an x minus 30. So if I replace x with an x minus 30 degrees, what am I doing to the graph? Translate 30 to the right. Okay? If I look at the second one, y equals sine x plus 2. What is my replacement this time?
Y with the y minus 2.
And if I replace y with y minus 2, what does that tell me to do?
Move 2 units up.
Okay? So now if we look at 3, what are my replacements on 3?
X with an x plus 60. And then a y with a y plus 1.
So if I replace x with an x plus 60 degrees, what am I doing to the graph?
Translate 60 degrees left.
Okay? So translate 60 degrees left. And if I replace y with a y minus, or sorry, with a y plus 1,
Let's put 1 unit down.
1 unit down. 1 unit down, sorry. Okay, and if I look at the last one, what are my replacements on the last one? Y with the y minus 45.
X with x minus 45.
So if I replace x with an x minus 45 degrees, what am I doing? Jessica?
The x, you're moving it 45 degrees to the right.
Okay. And Evan, if I replace y with a y minus 45, what am I doing?
Translating 45 units up.
45 units up, good. The units are important. I need to see the degree symbol with the translating 45 degrees to the right. Okay? Now, in trigonometry, these horizontal translations have a special name. It's called a horizontal phase shift. A phase because we're basically moving the period a certain amount. So period and phase can kind of be interchanged. So that's where we get that horizontal phase shift. And then the D value, or that vertical translation, we call a vertical displacement. And again, if we think of displacement in terms of our science class, we are talking about a movement. So if we look at class example number 2, it says complete the table to describe how the graph of the given function compares to the graph of y equals sine x, where x this time is in radians. So if I look at the equation y equals sine x, there would be no phase shift, and there would be no vertical displacement. Or I could write down 0. So the vertical displacement is 0, the horizontal phase shift is 0. What I would like you to do is complete the rest of the chart. Okay? What is the horizontal phase shift in the equation y equals sine x minus pi over 4? Pi over 4 radians to the right. So this time it's not degrees, it's radians, and the direction's to the right. What's the vertical displacement? None. Okay? If I have the equation y equals sine x plus 5, what's the horizontal phase shift? None, there is none. And what's the vertical displacement?
5 units up.
How do I know that the 5 was a vertical displacement and not a phase shift?
Because it's not in brackets.
Because it's not in the brackets. Okay? So if I look at the next one, y plus pi equals sine x plus 3 halves. What would be my horizontal phase shift?
Pi over 2 radians left.
And what would be my vertical displacement?
Pi units down. Or pi radians down.
Pi units down. So it's not pi radians, it's pi units. Okay, if I have y equals x minus c plus d, what's my horizontal phase shift? And what is my vertical displacement?
D units up.
Does it change if I add in vertical and horizontal stretches? No, because because my translations happen at the end. So this would still be C rads to the right and D units up. If I replaced sine with cos, would I get similar results? Yes. Okay, so the next page just summarizes the idea of the horizontal and vertical translations, the phase shift and the displacement. This right here basically summarizes what we've done in pretty much lessons 6, 7, and 8. So the amplitude, which is the absolute value of that A value, is the max minus min divided by 2. Then we have the period, which is 360 degrees divided by B, or 2 pi divided by B. Something to remember, if I went the other way, B would be equal to 360 divided by the period. So these two values could be interchanged. And this would be calculating the absolute value of B. Horizontal phase shift is my C value. When it's greater than 0, I go to the right. When it's less than 0, I go to the left. Remembering always that it's an X minus C replacement. So when C is negative, I get an X plus C value. And then my vertical displacement, if D is greater than 0, I go up. If D is less than 0, I go down. The vertical displacement is the center of the graph. So if my graph is a sine graph, the vertical displacement describes this, where this line is. So I can find that line by finding the average between the max and the min. So I add them together and divide by 2, and that would tell me where the vertical displacement is. So it's different from the amplitude. The amplitude is finding the distance, or halfway between them, so it's subtraction. So it says, consider the equations of the form y equals a sine b x minus c plus d, and if it's cos. The value of a and b are 1 at this point in time. So what equation would represent a cosine function having a horizontal shift, phase shift, of 75 degrees to the right? So if I'm going 75 degrees to the right, what replacement am I making?
X minus 75 degrees.
So I'm replacing x with an x minus 75 degrees. So in my equation, a is equal to 1, and b is equal to 1, so I now have x minus 75 degrees. There's no vertical displacement, and that's where it would stay. So I'm going to give you a moment, and I want you to try to do b. Yeah, that should be cosine x minus 75, not sine. Okay, now try to do b. So what are my replacements for b?
X with x plus 3 pi over 5.
Because it's going to the left. And what other replacement do I have?
Y with y minus 4.
So what does my equation look like?
Y equals sine and then brackets. X plus 3 pi over 5. And then close bracket plus 4.
Good. Okay, so class example number 4 asks you to find the amplitude, period, horizontal phase shift, and vertical displacement of the following functions defined where x could be a real number. So if I start with amplitude, what allows me to find the amplitude of a function? What value on the equation? The a value. It's the absolute value of a. So what's the amplitude? 2. Okay. The period. How do I find the period of the function?
36 or 2 pi over b.
How do I know it's 2 pi and not 360?
Because it's in radians.
And how do I know it's in
There's
radians?
pi
More than just that it's pi. What is it missing?
It doesn't have any degrees.
It doesn't have the degree symbol. And watch for that, because it could easily, I could tell you to shift it pi degrees. It really wouldn't be very logical, but I could still put pi degrees in there. Okay, so then I've got 2 pi. What is b equal to? 3. Can I simplify that anymore? No. So my period is 2 pi over 3. Horizontal phase shift. What's my horizontal phase shift?
Pi units left.
Pi units left. Is it units or radians? So pi rads left. And then my vertical displacement. 4 units down. Okay, they give you a couple of minutes and I want you to try to do B. So what is the amplitude of this function? Because amplitude's neither negative or positive. Okay, what about the period?
8 pi.
And how'd you get 8 pi?
2 pi over b, so 2 pi divided by 1/4.
Okay. What is the horizontal phase shift?
Pi over 12 radians, right?
And the vertical displacement?
3 units up.
Is question number 5 the exact same as question number 4? Or is there something different about it?
You'd have to take the 3x out of brackets.
Right. So I have to isolate that x variable. So if I remove the 3, I get x plus what? Pi over 3. Okay, so now I'll give you time to do both questions, and you're going to do the exact same thing. Amplitude, period, phase shift, and vertical displacement. Okay, so what is the amplitude on A? Two. The period.
2 pi over 3.
Good. The horizontal phase shift.
Pi over 3 radians up. Radians in there.
And the vertical displacement.
4 units down.
Okay. So for B, I need to isolate this x first. So if I factor out a 2, what am I left with the pi over 2? What does it become? Good job, pi over 4. So what's the amplitude? 1. What is the period? Pi, because it's 2 pi divided by 2. Horizontal phase shift.
Pi over 4 radians, right?
And the vertical displacement.
8 units up, or pi radians up.
Pi units up.
Is it units? Oh.
Yeah.
Oh, I have that.
So it says compare the answers of class example 4A and 5A. And what do you notice?
They're the same.
They're the same. Because the equation was the exact same. It was just written in a slightly different form. Okay, so let's give you some time to practice with this. There are a couple more practice questions. Question number number 1. B, D, and F. And then question number 2. 2B. Okay, so this next section looks at graphs and whether or not we can basically do the same thing given a graph of a function. Can you determine the amplitude, the horizontal phase shift, the period, and all of that stuff if you're looking at a graph? So if you look down this page, you'll notice that all 4 graphs are the exact same. But we're going to come up with 4 different equations to represent these graphs based on specific information we're given. So in the first question, we're told that the amplitude is positive. Okay? So the amplitude is positive. There's a minimum possible phase shift. So we're trying to take the shortest distance to move this graph. And we want this graph to be a sine graph. So let's start with the amplitude. When I have a graph, how do I find amplitude? Max minus min divided by 2. So what is the amplitude? 4. Is the amplitude going to change between the 4 graphs? No, it's always going to be 4. How I write it differs because if A is less than 0, it's now a negative 4, but the amplitude is still 4. Okay? The period. So when we're trying to find the period, we want to find a starting point to a starting point. So I guess maybe I could look at the y-axis and follow it till it reaches again, but it could be a little bit sketchy as to, is this point the exact same as this? So what we might find it easier to do is look at intercepts, because those intercepts are on the grid marks. Then what I need to know is, what is the scale of this graph? What do each of these tick marks represent?
Pi over 6.
How'd you get pi over 6?
Well, I saw there's like 6 sections between pi and the 0 spot.
So think of this as being one whole pi, and now I'm dividing it into 6 pieces. So the scale is pi over 6. So I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi's over 6, which is the same as 2 pi. Oh, I guess I didn't even actually need to know the period because it's not prompted in the question. Sorry. I need to know the value of C. C is my horizontal phase shift. This is the one that gives people a lot of trouble. What we have to go back to is, what does a sine x graph look like? So the sine x graph starts in the middle, goes up, comes back down. That's what the sine x graph looks like before I make any changes to it. So what I want to do is I want to look at, where does that match up? Right here. If I take this graph and slide it over to that point, it will match up. Or actually, sorry, not slide it over to that point, other way around. If I took this and I went backwards, because that's where I want sine to actually start here, because that's where I'm used to it starting. So how many places did I shift that?
2 units, or 2 readings
2 pi's over 6. What does that reduce down to? Pi over 3. And this is a pi over 3 to the right because originally I would have been here and I moved it to here. So then my equation would be y equals 4 sine x minus pi over 3. And when we say the minimum possible horizontal phase shift, because I could slide way back over to here. If I went over to here, that would also be a phase shift. Okay? So all this stuff I put the formula. Okay. What happens in B? What's the difference?
Oh, it says A is less than 0.
So my A value has to be -4. Okay. What does the negative do to the graph? What does a negative A value do to the graph? Think back of my replacements.
It's a reflection.
It's a reflection in which axis?
The Y or the X-axis.
Okay. This is important because this is going to help me with my phase shift. Because remember, what does sine x look like? Looks like that. If I reflect it in the x-axis, it's now going to look like this. So it starts off by going down. So if I look on my graph, where does it start to go down? Right here and right here. That's where I'm going to get this down, up, down, up. Which one is closest to the x-axis? The one on the left or the one on the right?
This is the Y-axis.
Yeah,
The one on the left.
the one on the left. This becomes my minimum phase shift. That's what the question means when it says the minimum. So my horizontal phase shift is 1, 2, 3, 4 pi's over 6. And what does that reduce down to, 4 pi over 6?
2 pi over 3.
And what direction is that? To the left. So my C value would then be, it would be a negative. So I've got y equals, A is -4, sine, if I'm going to the left, this would become x plus 2 pi over 3. Is that getting better? Okay, so what happens in C? It's now a cosine graph. Tell me about a cos graph. Where does a cos graph start at?
Starts at like the top of the Y-axis.
Starts at its maximum and then goes down to the minimum and comes back up. So it's important to understand what that general shape looks like. We already discussed before the amplitude did not change, so it's still going to be a 4. Now I look at my horizontal phase shift. So I want to start at the maximum point for cos. That can be here or here. But I want the minimum horizontal phase shift. So do I want to move it to the left or to the right? Which one's closer to the y-axis? The right. So how many units did I do that horizontal phase shift? 5 pi over 6. And that was to the right. So then my equation becomes y equals 4 cos 5 pi over 6, minus 5 pi over 6. And what happens in D?
A is less than
A has to be less than 0, so now what do I have?
Reflection on the x-axis.
So if I reflect this graph in the x-axis, instead of it starting at its max, it's now going to start at its min. That's what the reflected graph is going to look like. My A value becomes negative, and then my horizontal phase shift, I'm looking for minimum points. So I've got one here and one here. Which one is the closer shift? The one to the left or the one to the right? The left. And how many units did I shift that?
Pi over 6.
So what would my equation be? Y equals -4 Good. How's that so far? Good. Because now we're going to make it the harder ones. And not really harder, it's just now we consider all 4 variables. So we have to look at amplitude, horizontal phase shifts, periods, and vertical displacements. This is a sine function. The value of A is greater than 0. So that means we're looking at this kind of a shape. So let's first of all figure out amplitude. How do we find amplitude?
Max plus min divided by 2.
Plus or minus?
Oh, minus.
Minus. So we subtract them. So 1 minus -5 divided by 2. So what is 1 minus -5?
6.
6 divided by 2? 3. How do I find the vertical displacement? Add them. So 1 plus -5 is, divided by 2 is? Okay. The -2 tells me where the middle of my graph is. And the 3 tells me what the distance is between the middle of the graph to the top. So graph that y equals -2, just as a dotted line. So if I draw this dotted line through y equals -2, it cuts the graph in half. I go up 3 units, I get to the maximum. I go down 3 units, I get to the maximum. Okay? And that's gonna help us out in a couple of minutes. Now we look at the period. So again, when you're trying to look at period, you want to try to look at some markers that are going to help you. I can either look at intercepts, the x-intercepts, which really in this case aren't going to help because they're not really on a grid mark. But if I notice my max and my minimums are. So if I went from maximum point to maximum point, that's a period, whether it's the sine graph or the cos graph, because it's going down and then up, and then it's going to go down again. So if I count, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What are each of these tick marks this time?
Pi over 3.
Pi over 3, because from here to pi it was in thirds. So I get 12 pi over 3, which is equal to what? 4 pi. Good. Now I have my minimum horizontal phase shift. So remember, sine always starts in the middle and then goes up and down. But I have to use this line because I've shifted this up and down. This is where I want to look at. So if I look, I've got this part right here where it starts in the middle and goes up, or I've got this part right here. I want the minimum one. So is that to the left of the y-axis or to the right? To the left. And it's how many units?
Pi over 3.
So pi over 3 to the left. And now I want to translate all of these into my A, B, C, D values. So what's A going to be equal to? Okay. I'm going to skip around. What's D going to be equal to? I think I heard somebody say it, but not very loud. What's D equal to? -2. It's the vertical displacement. C is the horizontal phase shift, so what is it going to be equal to? Pi over 3. And because it's to the left, it would be a negative. And then B is, how do I calculate B? Two pi divided by the period. The period is 4 pi. So what's 2 pi divided by 4 pi? 1/2. So then I would get y equals 3 sine square bracket 1/2 curved bracket x plus pi over 3, close the 2 brackets, minus 2. And you can then check this on your graphing calculator. So if I said instead of A being positive, now A is negative, what would change? Would the amplitude change? What would the amplitude become, Jessica? You're nodding your head.
-3.
It would become -3. Would the period change? No. So the B value would still be 1/2. Would the vertical displacement change, the middle line of that graph? Would it still be at -2 if I reflected this? No, because it would reflect it here.
So it is -2.
Because I would have to do the reflection. That -3 is the reflection, would happen before I moved it up and down. So my D value would still be at -2. What changes is the horizontal phase shift. Because when I reflect that sine graph, it now goes down and goes up. So what I want to look for is where does it go down and then come up. And the minimum phase shift is the one that's to the right. 1, 2, 3, 4, 5 pi over 3 units. So my C value would become 5 pi over 3 this time. So then my new equation would be y equals -3 sine 1/2 x minus 5 pi over 3, because it's to the right, minus 2. Okay? I'm going to give you a couple of minutes, and I want you to try to start B. You're looking at a cosine graph, so I want you to see if you can figure out the stuff for B. So your homework yesterday were to write these two equations as a cosine function. So how would I calculate the amplitude of this function?
Max minus min divided by 2.
Okay, so 1 minus -5 divided by 2, which equals, okay? How would I calculate the period?
starts from the top, so,
But when I'm calculating period, I want to either go from a max point to a max, or a min to a min, or sometimes the intercepts. I want to pick points that I can easily find, because I want to look at that repetition. So if I calculate the distance from here to here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And each of these were a pi over 3. So my period is 4 pi. Okay? The vertical displacement, how do I find that one?
Maximum plus minimum divided by 2.
So what is 1 plus negative 5 divided by 2? Negative 2. And what is the vertical displacement represent on my graph?
like, center.
It represents the center of this cos function. Okay? And then when I do my horizontal phase shift, that's what you were referring to. So what do I do there, Bobbianne?
Well, you have to take your two, like, maximum points that, those two. And then you see, like, how many spaces it is from the,
Okay, why am I going to the maximum point?
because your cos graph, when you draw it, it starts from your maximum.
Yeah, because cos originally starts at that maximum point. So I want to see where that maximum point moved to. So what was my shift?
2 pi over 3 to the right.
Okay. So now when I go to write this into my form, I know that this is the value of A, I know this is C, and I know this is D. How do I figure out B?
2 pi.
Okay, so B is equal to 2 pi over the period, which was 2 pi over 3. So that becomes 2 pi. Oh, sorry, 4 pi, wrong one. I was thinking phase shift. Never mind. So 2 pi over 4 pi, 1/2. So then my cos graph would be y equals A cos B x minus 2/3, or 2 pi over 3, minus 2. Okay, is that what you guys got? Awesome. What happens if I change my A value to be negative? So if I start off with a negative 3, what gets impacted? Does the period change? Nope. So I can still have that cos 1/2. Will the midline change? Nope. So I'm still going to get a minus 2. The change is the phase shift. Because in this negative cos x, instead of starting at the maximum, I start at the minimum. So when I'm trying to determine that horizontal phase shift, I want to go to the closest minimum point. So this is a shift of how many units?
4, 5,
And in which direction?
left. So you add it. So it'll be x plus.
So it'd be x plus 4 pi over 3, because I shifted to the left. Good. Okay, last question. Or last set of questions. If I consider these two sinusoidal graphs, what of A, B, C, or D would change the domain of the graph? Do any of them affect the amount of space it takes up horizontally? Or do they just continue on and on and on and on? There is no change in the domain. Changing A, B, C, or D will leave the domain alone. What about the range? Those max and min points. What affects the max and the min points?
D.
D does. A as well. out, because A is that amplitude, it tells me to stretch it. So the vertical stretch and the vertical translation is going to impact the range. Amplitude. What value affects the amplitude? A does. What parameter, A, B, C, or D, affects the period? B. Does A affect the period? If I do a vertical stretch, does that affect?
Well, but when it's reflected, doesn't that change the period?
No, because if I look back on this, if I was going from minimum point to minimum point, this would still be a period of 2 pi. Okay, what about the zeros, all of the x-intercepts? Would changing the period change the x-intercepts? Yeah. Because the zeros are anything along the x-axis. If I change the horizontal phase shift where sine starts at, is that going to affect my zeros? Absolutely. What about if I shift the graph up and down? If I take a cos graph, this is my cos graph, and remember D is a translation up or down. If I move that thing down, did I move where the intercepts are? Absolutely. Does the amplitude affect the zeros? What does amplitude correspond to? What's happening when I change the amplitude? What kind of a transformation? It's a vertical stretch. So what coordinates are being impacted? The y coordinates. And the zeros, what are the y values at the zeros? They're 0. So if I stretch this, is that going to change it? No. The only time it will change it is if D itself is not equal to 0. So if I just slide this up and down, it's not a problem. But if I take the graph and stretch it and then slide it up and down, that A and D value will both have had an impact. Okay? Question B says, state the maximum and the minimum values of the function in terms of the parameters A, B, C, and D, assuming that I have a positive amplitude. So, if we go back to an example that we can see, we'll go back to this close one. How can I find amplitude? It's max minus min divided by 2. But if I don't know the maximum and the minimum, that's what I'm trying to figure out. What could I do to figure out that 1 is the maximum and -5 is the minimum? Could I use any of these numbers? First of all, which numbers could I eliminate?
The ones with pi in it.
Ones with pi, simply because they don't make sense, and also because the period and the horizontal phase shift have to do with the x's. So it's looking at the amplitude and the vertical displacement. So how can I use the amplitude and the vertical displacement to get to 1? Add them. How could I use them to get to -5?
3 minus -2.
3 minus, would be 3 minus -2 or -2 minus 3?
-2 minus 3.
-2 minus 3. So to find that wrong page. So to find that maximum point, we took the vertical displacement and added it to the amplitude. And then to find the, so it could be for A minus plus D. To find that page, we had 3 and we had -2. And I needed to get to an answer of -5. How would I do that? D minus A. Or -A plus B. Either way would work. So with that said, the maximum and the minimum values of a sine function give me my range. So I can use the equation without graphing to find the range of the function, using the values of A and D to find my max and my min. So what is the maximum of the function y equals 3 sine 2x minus pi minus 4? How would I find the max? -4 plus 3, which would give me, okay? And then how would I find my min? Which would equal? So then the range would be all the values from -1 to -7. Okay, so I want to give you questions 4, 5, and 6A. 7B is like this question that we just did, and then 8 to 12